Are we live?
Yes, we are.
Because I never heard a countdown. All right. Good morning, good afternoon, good evening, wherever you might be. Welcome to the Level Up Hour, where we contemplate containers, consider Kubernetes, opine on OpenShift. And we've got a really good show this week. We're doing a few new things here in terms of our platforming, so apologies for our late start, but hopefully things will get off to a smooth start and we'll learn a lot today. We're talking to Simon Seagrave, Principal Product Marketing Manager, Naina Singh, Principal Product Manager, and Roland Huss, Senior Principal Software Engineer. And we're going to be talking about a topic that is very, very much a hot topic these days, and that's serverless and Knative. And so, first of all, greetings. Thank you for coming on, our guests. And I also want to welcome back the man himself, Jafar Charibi, who has been absent for a while, but is now making his triumphant return to the Level Up Hour. And thank goodness for that, because this is a topic where I'm going to need him to jump in often and frequently. So welcome back, Jafar.
Thank you very much for the warm welcome, and thank you everyone for being here.
So today we are talking about serverless and Knative. And I'll be honest, when I first heard this term a couple of years ago, serverless, I was like, well, okay, what does that mean? And let's bear in mind that, the audience for the Level Up Hour has a lot of people who are in, system administration, system engineering roles. And the idea of serverless is a strange word because that's what we work with, and so first of all, we're going to want to dig a little bit into serverless and figure that out, and kind of find out more specifically, how does OpenShift support serverless and what is Knative? Okay. And so first of all, let's do a little bit of serverless 101. What exactly are we talking about when we say serverless? Simon, do you want to tackle that?
Unfortunately,
or maybe Naina.
Yes. Hi, everyone. This is Naina. Glad to be here, and thank you for the warm welcome. And I'm glad that you picked this topic. So, as you said, serverless, the name suggests that there are no servers, but that's not possible, right? So, what it actually means, I think, in that context is that you don't have to worry about servers. So we see lots of definitions of serverless today, right? And the snippets of code known as functions running is one of them. So let's focus on how Red Hat sees serverless. So it is a deployment model where you can run almost any container or functions without worrying about the underlying infrastructure and complexities. The additional benefit that serverless provides you is scaling up as your demand increases and scaling back down when your resources has been ideal enough, right? So these serverless apps, if you will, are stateless, event-driven, and hence distributed and elastic. So in a sense, what Red Hat sees is that the serverless is a feature of your platform. Another thing that I would like to add, that you said that it's been 2-3 years since we have been hearing about it. So we consider that space is still evolving, right? So there have been waves and phases. So if we try to chart it on a scale, phase one would be when we started hearing about functions, as you just mentioned, right? And it was very pivotal in making this popular, but it has its limitations like execution time, language choices, and all that. Phase, let's call 1.5, is when we realized that the serverless traits and benefits could apply to containers with the advent of Kubernetes. And Knative is one such technology that is bringing that serverless capabilities to the Kubernetes, right? And then phase two is where integration and state comes into the picture, where you can use all kinds of integration patterns, making you write all your applications in a serverless fashion, as well as integrate with your other codes that you have. Because we understand that most organizations would be running their legacy code, monoliths, modular monoliths, functions, microservices, so on and so forth. So you choose what best suits you. That's how I would define it. Roland, if you have something to add, please feel free.
Yeah, so actually, you're totally on the right track. So actually, serverless is really something. Okay, serverless is a nonsense term, right? It's something. It talks about serverless, but of course, behind everything there are servers. It's just that you don't see it, and serverless is really coming from a developer's perspective. So it's really something that you throw over your code that you have developed, and somebody is operating it somehow. And of course, there are many ways how you can achieve that. So AWS Lambda does it differently, like OpenShift does it. And Kubernetes is kind of a little bit of a step in the right direction, so that you really can really throw over a container image which contains your code, and then it's operated in some way. And hopefully you don't have to worry, but still you have access to the cluster somehow. And in some sense, serverless goes one step further to say, okay, you still you do not even see that server part there, and it's completely you have an API like in Kubernetes, but it still makes it much easier to deploy applications. You don't have to tweak around with low-level infrastructure things like volumes or other stuff like that. It's really a high-level abstraction. You have an application and you want to run that. So this is serverless in broad terms. And there are even more specific definitions around serverless. The CNCF, the Cloud Native Computing Foundation, has also created a serverless definition, which also goes in that direction. And I think one of the main characteristics for the serverlet that we are talking about is that you have a very flexible scaling. You can scale up arbitrarily based on traffic. So really based on the demand of your application, you can scale up. But also you can scale down to 0, which means that if your application is not used at all, you do not consume any resources and you don't have to pay any money for that. I think this is one of the biggest benefits of serverless. And many define serverless actually with this characteristic.
Right.
Yeah.
Well, so that's go ahead, Jafar.
Yeah, sorry. So just to joke around a little bit, you could imagine that instead of serverless, it's server worryless. So you have to less worry about your servers. So that's what's implied behind the serverless thing. And yeah, go ahead.
Please.
Yeah. So what would be interesting, I guess, is to sort of understand what are the main use cases or patterns that brought that type of usage and patterns as serverless. So you explained one of the things around application scalability and going back to 0 to save resources. So we hear also a lot about application, so event-driven applications or architectures. Is it something that is tied also to this type of new or emerging type of application of architectures? Would you say that this notion of event-driven architectures can also correlate in some sort with the
Right.
serverless paradigm?
So I would say that at very simplest and at its core, the serverless pattern is an event happened, and then it starts your app. So in case of Knative technology, let's say, it would start your container. That container will process your request, and the result would be produced, right? So at very basic of serverless, it is event driven. The event happens, your app comes up, and then results are produced. You also mentioned about the real world use cases, but let me come back to that one. So because of its that basic pattern, all serverless apps are event driven in nature, right? And that's where when you mentioned that does serverless works towards that? Absolutely, and we will talk more about that one. Let me get back to the real world use cases. We even have a questionnaire that we have prepared for our customers when they want to know, okay, what are my use cases? Where can I use serverless, right? So in a nutshell, I would say if you have unpredictable or bursty number of requests, right? You want maximum resource utilization. You also want to reduce your carbon footprint. Let's face it, if you use your resource to the maximum, then you are reducing your carbon footprint. You want to work towards creating event-driven applications, and Knative would provide the event sources, channel brokers, and all that infrastructure around it for you to be able to comfortably create the event-driven architecture. But more than that, because of the scaling, its ability to provide the abstraction layer on top of Kubernetes, you can also try different deployment strategies, such as like A and B testing or canary deployments, right? And your seasonal or periodically running workloads. And the one that's my favorite is, let's face it, Cube is complex, and you want to reuse the skills of your existing developers and focus them on the business value driven rather than figuring out the infrastructure worries, right? So these are, in my opinion, are the use cases and the event driven architecture that you just mentioned.
Yeah, so this is awesome, Naina. And if I can speak from my personal experience, I've been working with OpenShift customers since we embraced Kubernetes, so almost 5 years ago. And at some point, we came up with what we could. I don't exactly remember what was the feature name, but you had the ability to wake up an application when the route was accessed, for instance. But once it was awakened, there was no way to scale it down back to zero. So it was a good feature, and it was already, you had to manually, I don't remember the name, but make the application sleep. And at some point when it's accessed, it goes back online. So customers liked it, and they started asking, okay, now guys, how can we scale back to zero? Because I don't want the application to remain up. And then we started thinking about like looking at the metrics and saying, okay, so if you call the API and ask about the uptime of the application and say, if there were no incoming requests for the 2 minutes, then scale back the application to zero. And so it was, something very complex to put in place. And the beauty of Knative is that it's actually become part of the framework, and you don't have to care about this. It's automatically handled by the application and by the framework, by the Knative framework, I would say.
Yeah, absolutely. It is out of the box. You get all these benefits, right?
Yeah, exactly. So actually, the main use case that is really predestinated for serverless is this bursty workloads, which happens maybe once a year, let's just say. So let's think about Super Bowl, something like merchandise for Super Bowl around that. The time it's only once a year, and then you have a very spiky workload, and you have to scale up very quickly. And that is also where Knative is very, very excellent. It's not only in scaling down to zero, but also it can detect that there's a burst of traffic and then scale up immediately, not only one pod after each other, but all many pods immediately at once. So this is also something where Knative is very strong. And exactly this kind of non-uniform workloads, take like this. So this is something where serverless really shines and helps you to reduce your builds.
So I'll have a question about that, about the bursting capabilities, but maybe I'll save it for later. I don't know exactly how the conversation is going to go, but just to give you a hint, I'm thinking about the boot time, the application boot time. When you are bursting, at some point it was sort of a concern that needed to be handled. And I know that now we have a solution that was, especially when speaking about Java workloads. So I gave enough hints, I think, but
oh, come on, you've hit it enough. So let's just jump in with both feet. Let's go with it. Don't hold back.
Yeah. All right. So so what I'm referring to is basically one of the main advantages also of Knative compared to like using functions or such things is that you can use a variety of programming languages. So and you don't have to change the way you code your application, because you can code your REST endpoint with whatever language you want, for instance. And the Knative project is going to make it compatible with this eventing stuff. And one of the questions that rose regarding this bursting capability is, we know that Java is still one of the predominant backend languages in most enterprises, and it couldn't really fit well with this notion of burstable resources, because if the application takes 10 seconds to boot or 20 seconds to boot, even if it's a simple REST endpoint that needs to say hello, then it's not going to be compatible. So I believe Red Hat has worked towards making Java more burst friendly. So I was wondering if you could tell us a little bit more about it and how it plays with Knative and serverless in general.
Exactly. So you really hit a point here. So actually, we're talking. So cold start is really an issue with Knative, as you mentioned. So if you scale down to 0, we have to scale up at some point in time, and of course, then it depends how long the application takes for coming up. And as you said, Java is notoriously slow in this respect. And luckily, there's now a solution these days, also developed by Red Hat, which is called Quarkus, which is a Java runtime or a Java platform, let's say like this, which allows you to compile your Java application into a binary, which really gives you incredible startup time. So this is really in the 10 millisecond range. So if you have a Hello World application, REST application, it comes up in 10 to 20 milliseconds. And this is, of course, a super perfect fit for Knative and serverless, because there you need this kind of quick upscale and also quick downscale, of course. And this elasticity of this application is super important here. But you have also to be aware, it's not only the application that adds to the cold start time. There are a lot of other aspects as well, like scheduling from Kubernetes, like the kubelet needs to start up the container. This also takes some time. So it's a sum of different portions that add up. And application startup time, of course, is very important. But we are also trying now at the moment, we have a focus on decreasing the other components which adds to the cold start time, so that so one of our goals is really to come up to a cold start time which is below 1 second. So this is really one of the goals. Of course, it depends on the application itself, but actually, if you consider all the rest and you have a very simple application, then we really want to kind of not guarantee, but actually the target is really to get below 1 second. Because this is the time a user has to wait when it scales up from 0 to 1. Because one user is the unlucky guy who really fires up the application again. He has the first request, and he has or she has to wait until this application is up. And 1 second is kind of tolerable still somehow. And so this is the goal. And actually, we have a demo later where we will see some Quarkus code there as well, or not Quarkus code, but in Quarkus application. And we can also see how quick and fast it really scales up.
Yeah.
Yes,
sorry, go ahead.
I'll just add that, like you mentioned, because the serverless, the OpenShift serverless, which is based on Knative. So ultimately Knative, that brings those serverless qualities to containers. And we know that most enterprises are still using Java, right? And Java is coming back, and Quarkus has a huge role in it. One of the disadvantages of those functions code and the phases that we were talking about before is the limited choices that you could do with them, right? The scale up and scale down thing. Because you create the container, so the flexibility is yours. You choose what you want to work with, and we will bring the serverless to those language choices that you're bringing, right? So another teaser I would say is we are working towards something else, and we are going to talk about that a little bit in a later, but where even the container creation would be the construct responsibility. Okay. So you will have the flexibility, whichever one you want to choose. Yeah.
All right. And so, thank you very much, guys, for these comments, because it brings a lot of useful information to the audience. And just to touch upon this notion of being able to burst and minimize the boot time. So we spoke about the application itself, but as you mentioned, when you deploy the application, if it's spread out on hundreds of nodes, and pulling the images basically is the first thing that needs to happen before the pod can start on the node. If the application takes 5 milliseconds to start, but pulling the image takes a minute, then you're still going to face that issue where the whole time to boot up is still 1 minute plus 5 milliseconds. So I believe we added some capabilities with the OpenShift platform to be able to basically pre-pull the images on certain types of nodes in order to make sure that whenever it's going to have this request, the image is already going to be on the node, and it's going to start up as quickly as possible.
Yeah, this is definitely something super important, as you mentioned, because this also makes it more predictable with respect to the startup times, because you never know whether a node already has the image loaded or not. And of course, you don't have only limited influence on where your application ports are scheduled to. So pre-warming this kind of image cache, this local cache, is super important as well. And actually, there's no general answer from the Knative side. It's something really which is specific to OpenShift or other Kubernetes cluster, how they do this kind of pre-warming.
Yeah,
true.
Sure. All right, enough talking for me.
Yeah.
Well, so no, we are not nearly done hearing from you, Jafar, and we've had a few teasers put out here now. So, do we want to talk a little bit more about, more specifically and narrowly about Red Hat OpenShift Serverless, and very specifically, things like serving, eventing, and functions, and what that actually looks like within Red Hat OpenShift Serverless? Because we've already kind of gone down that road a little bit with some of the discussion, but let's explore it a little bit more.
All right, so I'll start, and Roland, feel free to chime in when you feel like I misspoke or something. All right, so OpenShift Serverless, being part of OpenShift, runs everywhere OpenShift runs, right? And is included in the OpenShift subscription. Knative is the upstream project that it is based off. In the Red Hat tradition, all of our products are based on upstream, right? This gives you the portability advantage and makes the hybrid cloud front and center of your solutions, right? So if we are going to talk specifically about serving and eventing, let me see. So in Knative, it hides the complexities and democratize this technology by using some modules that comes with it. The constructs that are serving that you just mentioned. So it allows your containerized applications to deploy as Knative service, that is, gives you the serverless qualities, and auto scale or scale back to zero, as we were mentioning. And all these services that you deploy are request driven or event driven. You can create different revisions of these deployed services, which lets you do those deployment strategies that I was talking about. Another eventing is the infrastructure that sends and receives these events that would trigger these applications that we just deployed using the Knative service. And the CLI command line that allows you to interface and interact with these constructs to make it easy to create the resources, doing the topology of your architecture, and you don't have to deal with YAML. This is basically in the Knative, and then we'll talk about what OpenShift Serverless adds on top of it a little bit later, because I want to give Roland time to talk about Knative a little bit here more.
Yeah, so that's really that. So Knative, eventing, and function, these are the pillars on which OpenShift Serverless is built upon. And Knative is an upstream project. And Knative is, as you might know, it's already, I think, 3 years old. It was initiated by Google. But now there are many companies which collaborate on Knative in the upstream. And it's really about these two parts. So serving is really about the auto-scaling part and about the revisioning part, and so that you have able to create customized rollout strategies. And the eventing part is the part for the event-driven applications, how you can connect those. There are brokers, there are sources that import events. Everything is based on cloud events, which is a standard in the CNCF. And actually, I don't want to talk too much about it because I can show you later on in the demo most of the concepts live, so it's easier to explain it live then.
So I will just add that we have made OpenShift Serverless extra special because we added the serverless functions based on Knative. This is in technology preview right now. When I say serverless functions, this is where all you bring is your code, and all the other worries are taken care by the construct. We will give you the scaffolding of the project, runtime of your choice, and then that would give you the jumpstart to write your code, and the construct would create container for you, and you can deploy it on your cluster in one step, right? We also provide a dev console experience on the OpenShift container platform. So OpenShift adds a lot more on what Knative provides. And this functions construct that we're talking about, we have recently donated it to the upstream Knative. So it is in Sandbox and incubation. So we are extremely excited about that. Oh, and OpenShift Serverless, I should also add that. How do you install it, right? Because you said, how do you do it? How do you install it?
That's what I was gonna ask. I was gonna say, from an admin standpoint, like, how do we install it? How do we maintain it and stuff like that?
Yeah,
Yes,
it just
yeah.
struck me that we are talking to the IT admin ops audience, and I just didn't cover the most important thing, right? So it provides you installation experience through an operator. You just click on a button and everything else is taken care of. It provides you automatic updates for your day-to. It provides monitoring dashboards. There are no external dependencies whatsoever. There's just click on a button and it will be installed on all your namespaces in your cluster.
Yeah,
It's pretty straightforward.
I might add, of course, you can automate this as well. So everything is based on the operator lifecycle manager, which means it's a standard mechanism that you create a subscription. This is also a CRD, a custom resource. So you can everything put in Git and automatically apply that. So you don't have to go via the UI where you press some buttons, but you can just put it into your automation scripts in Terraform or Ansible, something like that.
Okay.
Well, it sounds like it's pretty easy to get. There was a question that arose in my mind as we were discussing some of these capabilities and really what a substantial change working within serverless is. How does a developer transition to that world of serverless? Is it something that is a relatively straightforward thing, or is it something that maybe you first need to plug your head into event-driven applications and understand that sort of paradigm before you get into serverless? Or is it something that you do as part of getting into serverless? Or do you need to adopt serverless and then that's going to allow you to be more event-driven just sort of naturally? I mean, what is that process that a developer, or let's say a team of developers would go through to move towards a more serverless direction? Because it sounds great, but there's always going to be some sort of transition, right?
Yeah, too. So actually, this is also, maybe we forgot to mention, so Knative and serverless is really focused on a special kind of workload. So actually, everything is assumed that you are talking about stateless workloads. The reason why it needs to be stateless is because of this scale down and scale up facility, because you lose your state if you're down to zero. And therefore, you have to externalize your state to some external database. You have to refetch the state on each request, for example. So this is kind of a very hefty constraint, actually. But actually, if you have your application and you have kind of a microservice architecture, let's say like this, and you can really split up your stuff into stateless and stateful services, then of course, the stateless services are very good candidates for being operated with serverless. And so you have to think about on that angle as well. And also, it's important to know that the scaling, the typical the autoscaler from Knative and OpenShift Serverless is based on traffic, so on consumption. So it's based on incoming traffic. So it's always only really good for request-driven or event-driven applications that really have to process some incoming traffic. So it's not so much cannot used really for batch-like jobs that are running in the background and so on. So really, you have to categorize the parts of applications that can be operated with serverless, and you typically have a hybrid setup. You do not move everything to serverless. You have some mix and match between different components, and this is important. But actually, we try really to push the boundaries to include, for example, stateful applications as well, with, for example, including stuff like Cogito, which is a workflow engine, also coming from Red Hat and other stuff. So this is kind of the future, but at the moment, it's really only about stateless applications.
I think we are also forgetting to mention is it requests it serves the HTTP request as well. So you don't have to have Knative eventing paradigm, like you have to have Kafka or some kind of event-driven thing, right? You can have your application that is just going to be exposed to as an HTTP endpoint, the REST endpoint, and the Knative serving would work for those as well. So I think that's the one part we forgot to mention. So they don't have to have that event-driven. If they're thinking that I have to have an event bus or some kind of a messaging tool, only then I can write serverless applications. That's not the case.
Right.
Yeah.
So it's not necessarily the case that you have to have some event-driven tooling.
Yes.
But if we're thinking about the sort of the journey of an organization to, the sunny uplands of serverless, it begins with maybe starting with a more microservices approach.
Yes.
And then from the microservices approach, it really comes to identifying those things that you can run statelessly versus the things that of necessity need to be stateful. And then maybe once you've identified that, then there's that opportunity to move into something that's a bit more serverless, event-driven, and so on. And if I'm understanding correctly, that we're even perhaps going to push the boundaries at some point and start to be able to do more stateful things.
Absolutely.
But certainly where the first opportunity is if you've been able to segregate your workloads and be able to identify those things that can run statelessly. And that's exactly what it's made for, because of this notion that you can actually scale it down to zero, which the finance organizations of our customers love hearing, right?
Yeah, sure. And if I could add to that, so what you said, Naina, about the ability to still use serverless paradigm, even if you are just using simple REST endpoints, it can still be very beneficial if you are thinking about high scale. So, for instance, if you have hundreds of microservices and each one of these needs tens of instances or whatever, even if you are scaling back to zero just for simple plain HTTP REST services, there's still going to be some benefits to doing that. And when speaking about like stateless or stateful types of services, we can also imagine having things, intermediate things like caching to accelerate the, refreshing the data with things like data grid or Redis. So the time to access the data is much less than if you were directly talking to a database, for instance, to pull the data whenever the REST endpoint needs to serve back the responses. So yeah, you can have different levels of, I would say, evolutions in your architecture. You can bring those, I would say, different building blocks where you can have your simple REST endpoint, then you can have the caching stuff, and yes, caching services to sort of provide the stateful and externalized stateful pattern. And of course, once you go into more sophisticated things, then you can embrace event-driven applications by putting things like Kafka in play into the global architecture. So yeah, it depends really on the level of maturity of the developers, of the architects within the team, but you can still benefit from it at early stages in the architecture transformation.
Yeah, the operational benefits would be there, right? Regardless, if you just start at the basic level too, as well. Yes.
All right. Well, so I think that we've had some teasers and we've alluded to some things, and the time has come, perhaps, to actually watch some of this in action. So it's demo time. Stand back. What could possibly go wrong? But who is going to run our demo for us today?
So,
and what are we going to see?
We have no servers because it's serverless, so nothing can go wrong. That's my guess.
There you go. Problem solved.
Good one. Roland would be doing it. So. Yeah.
So far, so good. Roland, oh, wait, here we go.
If you are muted, Roland, we cannot hear you.
Roland, I think we lost your audio.
Oh yeah, better now?
Yes.
Sorry. Okay, this was hardware button. Okay, sorry. So you should see my terminal right now, right?
Yes.
Yeah.
Okay, cool. So actually, let me set a little bit of the context, what I have here now. So actually what I'm running in the background, there is an OpenShift cluster. So the server is not visible, but it's running, of course. And it has OpenShift Serverless installed. And what we are trying now, we are trying to create from scratch an application, and we are leveraging all components except of eventing from OpenShift Serverless. So we start with a function. So actually, what you see here now is an empty directory. And there you see KN, this is the Knative CLI, which is also delivered with OpenShift Serverless. You can directly download it from the administration console. And we have here a command which is called func, and this is for scaffolding an empty project. And we can select different runtimes or languages. So in this case, we are using Node. You can use Quarkus, you can use Python or Rust or what. So I think there are a handful are supported and more to come. So if I do that, And if you check now the directory, you see now some packages, which really gives you a skeleton of a project and of a microservice. And let's go into that, the main file, which is index.js. So actually, you have here a handful function, and this is kind of really, this is not a full server. This is really only a snippet of code, and this is evaluated by the function runtime. So this is a little bit, you can imagine this like Lambda, where Lambda is you throw over your function code, which confirms to a certain API or signature for a function, and then it gets executed by the Lambda runtime. And here it's a little bit the same, except that we will create a container image out of this. So what I have here now, we have several things. Of course, you can manifest. So actually, the important point is this invoke here, which is called by the runtime. So what I'm doing now is I just modify a little bit. You see you have already some default handler for get and the post, HTTP get and HTTP post. So what I'm doing now, I'm just deleting the get one, and I'm adding my own one. So I have prepared something here, which is looks like that. I'm going through this little code snippet as well. So what I'm doing here is I'm just importing some helper methods for sleeping some stuff, creating a UUID, which I return at the REST service. And what I'm creating is a simple REST service which just creates a random number and returns that in a JSON structure. So without evaluating any queries, of course, you can examine all the query parameters here as well, if you like. And then I see whether the environment variable sets a delay. So this environment variable is set in my container. And if so, I sleep that many milliseconds. And afterwards, I'm just returning this JSON structure with a random number between 0 and 1000, and then the ID, and then some other fixed labels like that. So that is kind of what I think this is a nice hello world kind of application. Let me get out of VI, which is already the most difficult part of a demo. Okay, so now we have the kind of code, and we can now build this one. So with kfunc build, you create a container image out of this code here, and this leverages build packs in the background. So, but you don't really see that. So first of all, it asks for some extra parameters, which is where it should store the final image if it's pushed. And now it's creating this image. This might take a little bit. So the first run is always a little bit slower than the other ones. And so what it does really, it starts the build pack. We have dedicated build packs for every language, for Node, for Quarkus, and others. And there is in this build pack, it's also contained the boilerplate to call your function. So here, in this case, I think there's an Node Express function which is wrapped around this code. So now it has been built, and the good thing is now you can all try this now locally, like with this run command. So this is something you don't need any cluster for that. It's just running locally here, and then it will tell you that it's running here on localhost. And let me call this one, and you see here some debug code. This is coming from the server itself, but the interesting part is really here that this is the return value which is coming from my REST server that I just have created. Okay, this is the first one. This is also a typical developer cycle that you develop locally. You have quick turnaround times for development. But if you're done, then you want to try out your code, of course, on a real cluster with the real Knative running behind that. So for this to do, you just need to run the same thing with kn-run deploy, kn-func deploy, sorry. And here in this case, it again builds the function image. You can avoid this by adding an option like -no build, I guess, or skip build. And then it pushes the image to a registry. This is the registry that you have specified at the beginning, and then creates the Knative service deployment. And I'd like to ask you to look at the top half of the screen where you see the pods that are running on this cluster. So at the moment, we don't have any pod running. So this is really a Kubernetes pod, which is running then on behalf of a Knative service. And now it's pushing it to the registry, and after that, it deploys to the cluster. And here you see that the container gets created. So this is one. So every time you install a Knative service, it just creates a pod at the beginning just to check out whether it really can be deployed, and to fail early if it isn't the case. So it always scales up to 1. If you deploy, you can tune this behavior, of course, as well. So now we have this deployment, and now I can just use this URL, and again curl this and look at the result, and you see now it's really coming.
Missing the M on the URL.
Oh yeah, sorry, I have here the M. Thanks a lot.
No. Yeah, sure.
Okay, having here. Okay, so you see now the same thing, but now served by the cluster itself. And if I continue to talk like this, then you will see that after 60 seconds, the service will scale down to 0 in the top. So then the pod will go here from 1 to 0 in the case. But actually, for the sake of the demo, I can make this a little bit faster. And for that, I can use KN again. So let me jump to the top of the screen so that I can see it better here. So I can use an upside. First of all, let's make a KN service list. And you see that we have a service which is called demo, which is the same name as the directory that I've created. And we can also see the versions of the service. So every time I change the service, a new revision is created. And I can see all the revisions like with this list here. Like that, so I have only one. And this revision gets 100% of the traffic if we go there. I can now make an update. So service update demo, I give this name. And then I say, I want to change here some parameters which influence the scaling behavior. So in this case, I want to say concurrency limit. Concurrency limit actually is the number, how many requests in parallel a pod can process. By default, this is 100. So this means that a pod, like the one that we have seen, can run 100 requests in parallel. And if your traffic exceeds this number, then a new pod is scaled up. To make it a bit easier, we will scale it, say, okay, we already want to scale up after 10 concurrent requests. And we also reduce the autoscale window, which means the window is really the time. It's an internal scaling parameter, but in short means also that if I set this, then if no request comes in after 10 seconds, then it scales down to 0. But it has also some other meanings for scaling up. Then it really also determines the sampling rate and other stuff. So it's a quite sophisticated algorithm, but I don't want to go into more details here. Okay, now we can see the revisions like that. And you see we have a new revision. So you see that's like really that every time you make a change, you get an immutable revision, and you always can switch back to an old revision. This is very nice for rolling out stuff or rolling back stuff even. In this case, we have 100, and you see immediately that it scales down to 0 after it's been started. We can curl that, but actually I just want to make a little benchmark test. So in this case, I'm running 2,000 requests with 50 clients in parallel. And if you look up here, you see also immediately that not only one pod is started, but also many pods at once that we are really about to serve this request. And actually, it's already done, so it was quite quick, even if it's the other has already processed that. But then, of course, after 10 seconds, it scales down again. Of course, this is only for the demo sake. Typically, you have a much, much longer time scale for that, for sure, to keep it more stable like this. And you also see that it's only not 5, but 6. And this depends because the scaling up doesn't happen if one pod is really full. It already happens by default after 70%, and then it scales up. So this also happens for that you really have a smooth transitions upwards if you have a bursty traffic like this. Okay, we can see again this our revision list. We have it, which looks like that. I'm just going back to the concurrency target, to the autoscale window to 60 seconds. I think this is much nicer now for the last part of the demo, where we are going to show you how you can make a traffic split. And I will explain in a second what a traffic split is, but let's see again our revision list. You see again, we have a new revision again, which is revision 3. You can also see the details then, what this revision actually really contains. But now I give this revision here, in service update demo minus. I want to give the revision 1 a name, a tag. In this case, I say this is the version 1 of my application. So I see again, and look at tag again, the revision. I see here now the tag v1. And gets still 100% of the traffic. Now let's try something new. Now let's try to make an update of our version 1 to version 2. But we want to make kind of a canary release. So say, okay, we do not want to roll out everything to version 2, but only a fraction of the traffic should be directed to this version 2. And, typically, this is 5% or 3%, and the remaining part are still going to the old revision. So you can really carefully examine your new revision and then roll out to 100% to the new revision afterwards. But for the sake of the demo, we make a 50-50 split. So in this case, I'm going here again. I make here service update demo. So I'm specifying here a new image name. So this happens to be the same demo implemented with Quarkus and not with Node.js. So, but I already have prepared that. So this has already been pushed to Docker Hub and it's fetched from there. But of course, you can use any image. And by the way, you don't have to use functions. You can always start with this on this level. So there's a Kane service create as well and just specify the image name. So this is the easiest way how you can deploy an application. And then the interesting part comes here, where I say, okay, I want 50% of the traffic to the V1 version that I have tagged. So V1 is the tag that I'm referencing here. And then there's also a symbolic reference, which is called at latest, which always puts to the latest deployed revision. In this case, this will be this new revision with version 2.0. So let's do that. So you see again, the new revision start up just to check that it really is ready to serve. And if I'm now running my curl again here, with this, you will see that on the long run, you get a 50-50 distribution of your thing. So in this case, I get again version 1 from the node runtime. Now let's try the other again, the same command. You see now you have the same again. Okay, this says here version 2.1.0, but okay, this is something. Yeah, we can quickly. Okay, this is 1.0. Actually, this should be 2.0. But never mind. You see that there's different runtime here. It's Quarkus and also a different format of UUID because I use a different syntax to use that. And if I continue like this, you see that you get not always round robin, but actually close to round robin 50% like that. So this is the way how you can make this canary release. And again, if I want to service update, I can say, okay, now I'm happy with the new release. And I say, okay, I set 100% to latest. I don't make an image update here. And if you now, you can also, of course, use service describe to see how the split actually is. You see now 100% is really coming to the new version. And now to do some final curls, and you see now that you always get the new one, which is kind of deterministic. So this is actually how the traffic split works with serving. And to be honest, actually, this is mostly it. So actually, you create a service, and if you know Kubernetes, you know to get your application deployed. It's not only that you create a deployment for Kubernetes, but you have also to create an ingress object. You have to create a Kubernetes service like that. This happens all behind the scenes by deploying this Knative service. So there's the Knative controller. Take this Knative service that you deploy. We can also look how it looks like in the YAML format. So maybe this is also interesting. Because you don't have to use, of course, you don't have to use this CLI. You always can use the direct CRDs like that. You see here that you have which is called kind service. It's unfortunately named the same like for Kubernetes, but you have a different API group. And this is how it looks like. So actually, the only thing that is really needed that you have to specify the image name. Every other thing is optional here. And if you deploy that, then the controller picks it up, and then you see we can quickly check if you look, for example, get the kube control service, sorry, the Kubernetes service. You see that there has been created a kube control service on behalf of the Knative service. You get an ingress on OpenShift. It's a route. You get a route object. Actually, I have. Well, it happens in a different namespace. Unfortunately, let me see whether I see it here. No, not really. Okay, but actually, you get the idea. So you get core Kubernetes objects created on behalf of a Knative service, and you only have to care about this Knative service. So this is more or less my demo, and I think we are open for questions now. I hope this was useful.
Yeah. So this was actually really fascinating, and it's interesting to me. I think there's a lot of advantages that come with serverless and this approach to applications. Scale up being one of them, but I think really watching sort of the scale down in action is fascinating, because for years scale up and scale out was always the thing that was concerned. But I think that there has come to be this understanding that if you're only looking at things in one direction, scale up, it eventually gets very, very expensive. And there is as much need to have an orderly way of scaling down as to scale up, and to manage, these different revisions while you're scaling up and while you're scaling down. It's this is really interesting stuff. So we started a little bit late, so we're going to go a little bit late today. And I just want to encourage anybody to post questions that you have for our guests. But James actually posed a more general question, which is better to learn on, Cloud, Kubernetes, or Minikube? And Jafar, I think you have some suggestions on that before I jump in with mine. Jafar, what do you think?
Yeah, sure. So I was doing a show this morning and with one of my colleagues, Natalie, and he asked me, so Jafar, what's your best advice for someone who wants to learn Kubernetes or OpenShift, for instance? And I said, the way I've been always doing stuff is I've been a hands-on guy. So I'm always looking for an environment and tangible practice. And that's the only way I can learn things, and not necessarily by reading stuff, because it doesn't teach you how things work actually in real life. So I would say my answer to the question is both, and any, as long as you can practice. So that's from my perspective.
I think the hands-on piece, is the critical part. And
exactly, yeah.
And so, go ahead.
Go ahead. So I was gonna say, in order to ease up the learning process and the experience for anyone who wants to experience this type of technologies, we started offering what we call the Developer Sandbox, which is a free-to-try offering of OpenShift. So all you have to do is hit the URL that we're going to share, and then you can create, I think it's a how long it lasts, 30 days or 30 something days. Like that. 30 days. It's a 30 days OpenShift environment there where you can experiment and you can learn and practice. So I would say, whatever works for you is best. And we are doing things to make it even easier for people to embrace that, because if you wanted to use Minikube or CRC or whatever, you need to have a laptop, you need to have a container runtime available, you need to do a lot of pre-flight stuff to make it work. Now with this type of solutions, all you have, all the prereq is a web browser. Hit your web browser, subscribe, and then you have your Kubernetes/OpenShift environment, and you have much more than what Minikube can offer, which is all the OpenShift UI, all the components, all the marketplace that we offer, and stuff like that. So long answer short, whatever works for you. And we are providing environments where you can easily provision your own OpenShift. There's also learn.openshift.com, where you have a lot of resources that gives you a real environment also where you can experiment. And it touches upon many topics, DevOps, security, Java with Quarkus, serverless, service mesh. So I would advise you to go there also, learn.openshift.com, and then check out the different tutorials that we have there. So I think it's pretty useful also.
Well, I'm going to have to jump in with one more, and I usually try to restrain my pitchmanship here, but as the director of certification, I do have to weigh in and say that if you have the ability to participate in sort of our training and certification offerings that we offer worldwide, that's a great way to actually learn about containers and Kubernetes. Last year, we introduced containers as a must-know topic in actually our core Linux curriculum, because it's become something that you need to know if you're going to be that Linux administrator. But then we have a whole series of courses and certifications that are focused on Kubernetes and OpenShift. And so if you're looking to learn, certainly use some of those free resources that Jafar mentioned. We are doing everything we can at Red Hat to make those kinds of things available. But if you really want to condense down the trial and error, be on a directed path to learning and a very hands-on path, to Jafar's point, please do look into Red Hat training and certification and what we offer there for learning. It's very comprehensive. It's growing. We are covering things not only like OpenShift and Kubernetes, but we are also covering things like server mesh and Quarkus and all of these sort of adjacent technologies that are all part of that big, beautiful whole. So with that,
I would just add one more thing. We do have some free downloadable books. One of them, Kubernetes pattern, is from Roland Huss himself. So we'll provide the link for that. We do have a Knative cookbook that is available to download from the Red Hat developer side, and tons of articles on the Red Hat developer side as well.
Okay, I want an autographed copy.
Yeah, and actually we jumped right into the questions, but I wanted to thank both Naina and Roland for the excellent demo. It was really awesome because it was pretty straightforward and explaining in simple ways the value of using serverless. So thanks a lot.
You really did illustrate it very well, and we got to the end of it successfully too. So yay!
So great.
All right. So I am going to have to kind of wrap us up here with what we usually close our shows with, and that is the sweet internet points. So I just wanted to announce that we are going to be putting the sweet internet points program on hiatus. It will be back next year, bigger and badder than ever, but we are putting a pause on it for now. But I did want to share who our top points earners are. And those are NIHACM, which I've never known how that's supposed to be pronounced, but there was a very neck and neck battle between that watcher and Narendev, who I think led the way for a very long time. Noah Friction, Bacon Fork, Det Conan, Kudo, Joe Fuzz. I'm saying all this with a very straight face here. How do you say Joe Fuzz with a straight face? JP Dade, MIK 310, M Roach, JP Dade. Those are our top finishers in terms of the points. Thank you for registering for that. We are going to be reaching out to our top points earners with a little bit of free swag. Let us know if you haven't heard from us. Thank you so much for having watched and participated in collecting those points. And again, we're going to revive the sweet internet points in 2022 more comprehensively, better than ever, I'm told. We'll see. So with that, I just want to remind everybody also to share, like, and subscribe. Let people know about the Level Up Hour. I think your family needs to know, your friends. It has been shown by science to make you more popular. So with that, thank you, all our guests. Thank you for watching today, and we will see you next time.
Thank you, everyone.
Thank you for having us. Thanks a lot.
Thank you. Bye-bye. And have a good